Hey everybody, it's Mrs. C. Listen, this video is a little bit different in that when I'm doing the review, these are systems of equations that we're looking at. I am not going to be solving the entire thing. What I'm going to be doing is showing you how to set up the equation, because I find that with my students, that really is the hard part. They can do the system where they actually have to solve it, but where they struggle, and where I'm thinking you might be struggling as well, is just how to set the thing up. So let's take a look at these two equations. I am going to write them a little bit bigger, where we have y is equal to a negative 3x plus 5. And in the other equation, we have 5x minus 4y equals negative 3. And now, what I find that students have the hardest time is when they look at their two equations, first of all, even identifying what method they should use. So the methods that we learn about, and I'm going to write them, it's going to be a little messy. I could have organized myself a little bit better. The methods we have to choose from are, there's really three. It's substitution. How about a different color? Okay, take it out. Don't take my 3 away. Oh my gosh, hang on. All right, how about a different color? All right, it is the choices we have. I'll put them up here. Substitution. You don't mind if I abbreviate, right? Thank you. I'm going to spell them wrong anyway. Substitution. We have elimination. And elimination is sometimes called the addition method. And then graphing. These are really the three big players. There is another method, people that use a graphing calculator, called the matrix. That's also a valid one for maybe my Algebra 2 peeps. But these are the three that we use for Algebra 1, and we really focus in on these two, the substitution and the addition or the elimination method. So what I find is people struggle with just trying to pick one of them. And so if we look at our little equation here now, our little system of equations, we now will struggle with the same question, right? Do I use substitution, elimination, or graphing? Well, let's just get rid of graphing for now. If you have a graphing calculator, you can solve all of them by graphing. But usually if you're being asked to use an algebraic method, you're not graphing, and it's not a very accurate method if you don't have a calculator. So bye-bye graph. We'll talk about you in another video. And in fact, I do have some really fun videos on graphing, but we won't go there. That's a senseless plug. All right, so it's substitution or elimination. Listen, it's really very straightforward. If you have a situation where you have a variable y, I'm going to make him a little extra colory here, and that variable y is set equal to an entire quantity, and everything, we call it isolating the variable. The variable y, and it could be the variable x, has been isolated like it has in this case. We use the substitution method because it is just the fastest method ordinarily to go with. So you just ask yourself, in my other equation, do I have a y? Yes, it's right here. I'm going to color you. Maybe yellow wasn't the best idea, but it's not the best color, showing color. But anyway, yes, I do. I have a y in my other one. Okay, then. So whatever that y was set equal to, and in this case, it was a negative 3x plus 5, you are going to swap in to the other y. So let me show you what that looks like when you actually write it out. Definitely not in yellow. Okay. If I was to take the value of 3x plus 5 and swap it into this y, it would mean I would be writing a negative 3x plus 5 into that position that the other y held. That little y contains negative 3x plus 5 because I'm showing it right there. Look at it. Y equals negative 3x plus 5. So if there was a y there, and that y is equal to a negative 3x plus 5, then we could substitute negative 3x plus 5 for the variable y. And you might be asking yourself, why would I want to do that? Well, because you're going to be able to solve it if you do. So let me just play this over again, but maybe without so much writing this time. This is a little bit too much writing. What am I doing? I'm supposed to be erasing. Uh-oh, you see what I'm doing. Sorry, I was hiding those because I didn't want you to see them. Cover that up. Okay. So I take a screenshot of some worksheets, some problems on the internet, and then I just plop it here, and instead of erasing, now you know I cover it with white. Okay, so when we had our problem, I'm going to write it a little bit bigger here and cleaner. Y equals a negative 3x plus 5 and 5x minus 4y equals negative 3. We look for a variable that's isolated. Here it is. The y is by itself, so I circle what y is equal to, and I swap it in to the position where the y is in the other equation, and I rewrite it. 5x minus 4 times the quantity of what? What am I swapping in for y? You got it. Negative 3x plus 5. Now it's not sideways, right? Looks so much nicer. Equals a negative 3. All right, now look what you did. Look what you did. What you did was you set up what was a system into just a regular equation, so that when you actually solve this out, you will get what x is equal to. Now that's a big multi-step equation, and remember I said we're not going to do that. X is equal to 1. I already peeked. I already did the problem. I already know x is equal to 1. If solving a multi-step equation like this is too saucy for you, then you need to stop this video right now, go to one of my videos on multi-step equations, and get better at that before you attempt a system. Once we figure out that x is equal to 1, and I know it's going to kill you, you go ahead, you stop the video right now, and you find that x is equal to 1, and then come back to me. Once we find that x is equal to 1, we're not done yet, because if you remember, up here we had x's and y's. So what are we supposed to do to find the y value? Well, let's look back up in the original equation. Let me change my color. We had an x up here, and we said x is now equal to 1, right? Well, if x is equal to 1, and it's negative 3x times, right, negative 3 times x, then what would y be? Well, evaluate this bubble that you made. Negative 3 times 1 is negative 3. I'll write it right here. Negative 3 plus 5 is 2. And so we find that the y value is equal to 2. So we do, hold please, I gotta move, we do another substitution step. Now, a lot of your teachers and a lot of answer keys are going to show this, most of them are going to show it as an ordered pair. Don't freak out. An ordered pair is just the x value first and the y value second. So you're going to see answer keys that show the solution to the system as 1, 2. Now, there's a check step that you can follow. The value of 1 and 2, meaning x is 1 and y is 2, will work in both equations. Now, I just proved it works in the one that I just solved, right? Because if you remember, and I'm just going to bring it back here, we just solved up here that y was equal to 2. So I could actually show, if I could get my marker to work, thank you, that y is equal to 2. That means both sides of this equation equal 2. And we just did the math, so we know that. But we didn't check this one to make sure both sides equal 2, because that's what an equation must do. It must balance. So if we come here and we just clear our space a little bit, we can actually check step that. And I'm going to do that because this is more of a process kind of a video. If we knew that the x value was 1, and we think that the y value is 2, then that all has to be equal to a negative 3. Let's do the math. 5 times 1 is 5, minus 4 times 2 is 8, and that's supposed to be equal to a negative 3. So what is 5 minus 8? 5 minus 8 is negative 3. Oh, look at that. That checks out as well. If both sides of these two equations, when you sub in these two values, are equal to each other, you've got a check step that proved out you did it right. I'm so proud of you. Okay, now let's try another one. All right, under here, I have another, look at that. I have another little problem. So let's get rid of this. I think you should copy that problem. I really do. I think while I'm spending all this time erasing, you could be starting. Don't just sit there and watch me erase. Get to it. All right. That way, you're not just sitting there watching me erase. Though it's fun, right? It's kind of therapeutic. Not really. All right. This one I haven't actually solved ahead of time, so this should be fun. All right. Take a look at this problem, and I would make it bigger. Let's just make it a little bit bigger. Look at that problem. Look at that pretty problem that's now a little bit blurry. Okay. Do we have a variable that's isolated? Do we have a variable that's isolated? Yes, we do. Right here. The y value is isolated, and it's equal to a negative 5x minus 17. That means anywhere that I see a y in the other equation, I can substitute the value of negative 5x minus 17 into it. Let's do it. Negative 3x minus 3, stop. What is y equal to? It's equal to a negative 5x minus 17. And then what's all that equal to? It's equal to 3. So you're going to notice, if you do a really quick visual check step, that this equation that I just wrote is exactly the same as this equation, except the y value has been substituted for the other one. And now, guys, you are good to go to solve for x. Once you solve for x, you swap in the value of y. So once you solve for x, you will have the value of x, and then you'll know what both equations' x value is. Let's try that. Okay, this time I erased so you didn't have to stare at me while I was erasing. I want us to try this. Now, you hopefully right now want you to pause that video and solve for x for me. When you get back, I'm going to have the whole thing written down again, and we're going to talk about what do you do once you get the x. But first, what I want to do is I just want to go over one more time the substitution method. So we have y isolated equal to a negative 5x minus 17. So we come over here and we rewrite the other equation, right? Negative 3x minus 3. Oh, I'm swapping in the value of y. It's negative 5x minus 17. And that was equal to 3. We solve and we get, this is a big reveal, spoiler alert, negative 4. Now, I peeked at the answer key and I talked so long I don't remember if it was negative 4 or positive 4, so we're going to find out. So anybody looking going, oh my gosh, I got positive 4, it could be right. I'm going to show you, first of all, how to check to see if you're right, and did I look at the answer key right or wrong? Who knows? I don't know. For those of you watching with no volume, not sure if that's right. You're going to be confused, so you should watch with volume. Okay. Once we know that y is equal to 4, we swap it in to that equation. Y is equal to 4. When x is equal to negative 4, we swap it in for the x. So we say y is equal to a negative 5 times negative 4 minus 17. I like that better because my number is going to be smaller. This is going to be a 20 minus 17, which gives me 3. So y equals 3, positive 3. Now the question was that value of x is equal to negative 4 correct? And I'm going to show you how you check. Well, I already did show you, but I'm going to show you again. Remember, both sides have to equal. So since I just did the math on that other equation, I'm going to swap it into the bigger one, the one on top. So if I think negative 3x minus 3y equals 3. Okay, if I think that the x value is negative 4, I have to put it in there. And I think the y value is positive 3. If that's true, then both of those together on that left side will give me the value of 3 on the right, because that's what the equation says. Let's try it out. Negative 3 times a negative 4 is a positive 12. Negative 3 times a positive 3 is a negative 9. 12 minus 9, yep, is 3. And that's that value. So I did copy the answer correctly. And as an ordered pair, it's a negative 4, 3. Okay, now the next ones we're going to do, I'm not going to talk quite as much. Well, I'm going to talk, but you know what I mean. So I'm going to, let's just erase this. Nope, don't do that. Let's just erase everything so you can see the whole page. We got some problems down at the bottom. I got an easy one that has a tendency to confuse people down at the bottom, and then I have a more complicated one. It's not really hard. It's the same as all the others on the right side. So let's just hit the one on the left, bottom left. This one's easy. Ready? I said I'm not going to talk quite as much. The y is isolated. Yes. So you swap it in for the y value of the other one. This one, sometimes in that it's a little bit easier, it confuses people. So I'm going to write the big one, and I'm going to swap in the value of y, which is negative 2. So I would wind up with a 4x minus 3 times the quantity of just a negative 2 is equal to 18. And I would solve for x. This one's so straightforward, I might as well just do it. I think it would take me less time than to go to the answer key. 4x negative 3 times a negative 2 is, you got it, 6, equal to 18. We're going to minus 6 from both sides. We get 4x equal to, what's 18 minus 6? I'm waiting. 12. Divide by 4. We got x equal to, I'm going to write it over here, 3. Now, what do? Once you know that x is equal to 3, in this case, nothing. Why? Because I already know what y is equal to. They actually told me these problems have the work because I'm already done. Now, you do want to double check that you're right. So, in the case of a problem like this, you actually want to try this problem out, but sub in the value of x as a negative 3 and make sure you actually get 18. But since we solved x in this problem for 3, not negative 3, I know I'm good to go, but I'm going to show it to you anyway just because I hate to leave a problem hanging like that. Always your check step is to sub everything in. So in a case of a problem like this, it's no different. We just do 4, what was the x value? 3. We're doing this, guys. We're just copying this problem. Minus 3, and this time it times a negative 2 was the y. That all has to be equal to 18. And so because this is 12 and this is 6, this is 18. I don't like these as much because I feel like I can't double check as much. And it's true because they had already given me the y value. Okay. Next one, we're going to do the other one. Now, the other one's a little bit more work, though it looks a little bit more familiar to you. So I want you to take a minute. This is how you got to do these videos. Stop. Don't listen to me. Do the problem and see if you can set it up. Don't solve the whole thing, because if you set it up wrong, you're going to spend a lot of time. You set it up, and then come over to me and see if you set it up properly. Okay, pause it now. Okay, hope you paused it. Okay, here we go. Now, what I'm going to do is I'm going to identify that, because that has the y's by itself, and I'm going to copy in all that into that little y. So we have a negative 3x minus 2 times the quantity of 5x minus 7, close parentheses, where did I leave off, equals a negative 12. That was what I told you to come back to me and show me that you had actually done the substitution step properly. The rest is solving a multi-step equation. That's not the hard part for you because you've already done this before. So pause now and solve for x, and then I will wait. Okay, so spoiler alert, x equals, again, I totally forgot what the value of x is. Guys, gosh, it was either a 2 or a -2. Let's go with a -2. But is that correct? We're going to use our check step to verify, right? Well, I don't have a check step yet. I would have to plug that in. So if I plugged a -2 in here, I would get 5 times a -2, which is a -10. That would give me a -17 for y. Is that correct is the big question. Well, let's do a quick evaluation step. If I copied, where is it? This problem up here. All right, let me just erase. And I'm going to recopy the big one. So I always want to recopy. I want to do my check step in the other equation, the one that I didn't actually swap in. So that's the -3x. Now, what did we say x was? -2. And it was minus a 2. What was y? -17. And that was equal to a -12. So we do the math and we see if we actually get both sides equal. And in this case, both sides have to be equal to a -12. So this would be equal to 6. And this isn't looking good for me, is it? 2 times 17. 17 times 2 is 34. Oh, boy. That's not going to be equal to a -12. 6 minus 34 is not equal to -12. What does that tell me, guys? If both sides don't match, it tells me that one of my, either I screwed up on my check step, or one of my x, or my x value in this case, was wrong. And I'm going to be honest with you, I did that on purpose. It wasn't a -2. Pretty sure it was a +2. I'm pretty sure that x was equal to a 2, not a +2. But in order to verify, we're going to actually do that out. All right, let's see. I'm trying to, hang on one second. Okay, I'm just going to replay my little check step here. Oh, check step, check step, check step. All right, let's see if I'm right. Did I copy it? Did I look at the answer key right the second time around? All right, if x is actually equal to a +2, then I'm going to rewrite -3 times a +2 minus, well, we still have to find, what, oh, shoot, I forgot what my y value was. What was my y value? Oh my gosh, I'm a silly goose. I don't have a y value. That's what it was. If my x value, we're going to play back a minute, if my x value had been -2, then I had come up with, what was it, 17, I think, as my y value. But if my x value isn't -2, I need a new y value. So what is y going to be equal to if x is a +2? We got to do that math. What's 5 times 2? +10 minus 7, 3. So now I have a new value. And you got to remember that if your x value changes, your y value is going to change as well. And so that's where these things can be dangerous, because one little mistake just throws everything off. We have a new y value in town as well, and it's a 3. These two little guys have to give me a -12. Oh, they do. I'm looking at them. This is -6. And this is -6, which gives me -12. Whew! So what do we see, guys? We see that substitution isn't complicated, but there's process involved. You have to go slow and steady to not make mistakes. And you need to do a check step to make sure you're doing it right. So I hope this was helpful to you. The substitution method is an awesome process to use when the problems are set up for you. Now, one thing I would like to do is I'm going to pause and I'm going to show you a screenshot of problems. So give me 1 second. Well, it's going to take me a second. It's going to take you no time at all. Okay, here's the screenshot for you. Now, this came off of CUDA software, right off of the internet, cudasoftware.com. And I'm showing you the screenshot with the answers because there's a couple things for you to see. Number one is that all of these problems are not set up to be quite as easy as the ones before. So on my next video, I'm going to show you how to set these up for substitution. Now, when I look at these guys, these don't scream substitution to me. I would actually use a different method, one that's called, we said, the elimination method. But a lot of teachers and a lot of worksheets will actually tell you to use the substitution method for these problems as well. And a lot of students don't learn the elimination method because they don't like it. I just think that's crazy, guys. Elimination method way faster on problems like this. But next video, look out for it, because it's going to show you how do you do problems like this using the substitution method. You can try these out, but what I would suggest is, if you see the complexity of these, you might want to, if you can't figure out how to get the y by itself, you might want to take a look at my next video. Until then, guys, it's been great spending almost half an hour with you, right? You know what is going to happen. I'm going to see you on the flip side. Later.